Most of what we're going to cover is applicable to all diesels, but since the 6.2 is the most widely used diesel in light-duty GMC trucks, we'll use its fuel system as our diagnostic model. We'll cover hard starting, rough running at idle, and other symptoms which can be traced to problems in the fuel system. This is the system for the 6.2-liter V8 diesel. The diesel currently available in GMC C and K models, vans, and P models. It consists of a fuel tank with water sensor, screen filter, and siphon system, a primary fuel filter, mechanical fuel pump, secondary filter, fuel line heater, injection pump, high-pressure fuel delivery lines, fuel injection nozzles, and fuel return lines. This is the primary fuel filter. On C and K trucks, it's mounted on the bulkhead in the engine compartment. A drain valve at the bottom allows for removal of water trapped by the filter. Fuel is drawn from the tank through the primary filter by this mechanical fuel pump and pumped through the inline fuel heater and then through the secondary filter mounted on the air intake manifold. Filtering of the fuel is vitally important in all diesel vehicles to prevent water and other foreign material from reaching the injection pump and nozzles. This is the Stanodyne injection pump on the 6.2, gear-driven from the camshaft. It's a high-pressure rotary pump that delivers a metered pressurized fuel charge through these high-pressure lines to the injection nozzles. Excess fuel from the nozzles is returned through these lines that run from nozzle to nozzle and back to the fuel tank. The 6.2 uses Bosch nozzles. The thread is different on the 1982 version as opposed to the 83, so they are not interchangeable. If you should have to replace a nozzle on a 6.2, make certain you have the correct nozzle for the engine you're working on. A still different version of this nozzle, a shorter one, is for G-vans only. Let's turn our attention for just a moment to the 5.7-liter V8 diesel, an engine you'll find in GMCs dating back to '79. The 5.7's fuel system is similar to the 6.2's. Both use a Stanodyne injection pump. A major difference is in the injection nozzles. Most 5.7's use this pencil-type nozzle. It doesn't screw into the cylinder head like a Bosch nozzle, but rather is pressed into its bore in the head and held in place with a clamp and bolt. Tool J29082 makes it a lot easier to remove the pencil nozzle. You're also less likely to damage the nozzle using this tool. There are two seals on these nozzles, a carbon dam seal near the tip and a compression seal under the collar. Both seals should be replaced whenever you pull one of these nozzles. Failure to replace the carbon dam seal may allow combustion gases to escape past the reused seal. This results in an accumulation of carbon between the nozzle body and the bore in the cylinder head. This carbon buildup can make it very difficult to remove the nozzle the next time around. Now this is the other nozzle you'll find in certain versions of the 5.7 diesel, a poppet-type nozzle. It screws directly into the cylinder head, much like a spark plug, and requires no clamping pieces, as does the pencil nozzle. This one differs from the others we've seen in that the nozzle valve opens outward into the combustion chamber each time fuel is injected. The others we've looked at have inward opening needle valves. Another difference is the absence of a fuel leak-off system. That brings us to the 2.2-liter four-cylinder diesel available in the 1983 S15 and Jimmy models. While none of the parts are directly interchangeable, this engine has the same basic fuel system elements as the engines we've just seen. The 2.2 uses a single fuel filter. At the bottom, it's fitted with a water sensing element. On top, you'll find a hand pump which can be used to pump water out of the filter when you open the drain plug, or to pump fuel forward into the injection pump when you want to prime the system. There is no external fuel pump. Fuel is brought up from the tank by the fuel supply pump built into the injection pump. The 2.2 uses a diesel Kiki injection pump, a lightweight rotary pump similar in concept to the Stanadyne. However, this one is driven by a cogged belt rather than gears. The nozzles are conventional needle valve type. Fuel enters through a side inlet port. The fuel return passage is on top. The opening pressure is adjustable on these injectors using an internal adjusting screw. When a diesel engine is hard to start or runs rough at idle, there are several possible causes. But one of the most likely and easiest to remedy is air leaking into the fuel system. The slightest leak anywhere in the system, particularly on the suction side of the pump, can cause a hard start or roughness complaint. Remember, too, that the supply side of the fuel system operates under a slight vacuum, so there may be no visible leakage of fuel. It's not a matter of fuel leaking out of the system necessarily, but rather air leaking in. To check for air leaking into the fuel system, install a short length of clear plastic tubing into the return line at the top of the injection pump. Start the engine and look for air bubbles or foam in the line. If you see this, then air is leaking into the system at some point. Check all fuel system lines, clamps, and fittings. Pay particular attention to the filters and fittings. On some vehicles with hard start and rough running complaints, factory engineers found almost invisible hairline cracks on the primary filter housing, which allowed air to be ingested into the system. Replacement of the filter housing cured the problem. Another method of locating air leaks is to pressurize the supply side of the system. Disconnect both fuel lines at the tank unit, plugging the smaller return line and then pressurizing the larger fuel line. A hand pump is preferable. Apply 8 to 12 pounds of pressure. Any immediate drop in pressure tells you there is a leak, and fuel will be forced out at the point of leakage. Now, once you've located the spot, making the repair is usually a simple job. If the diesel complaint is not only hard starting and or rough idling, but also a condition where the engine starts and then dies, the problem could be in the fuel return line. A distorted hose like this on a fuel return line can cause rough idle, hard starting, and a condition where the engine starts and then dies. Why? Because a restricted return system tends to retard injection timing. Retarded timing, in addition to the symptoms just mentioned, can produce a continuing white smoke condition. Now, white smoke is considered normal when the vehicle is first started, but should stop as the engine warms up. To check the fuel return system, remove the fuel hose from the metal return line at the injection pump while the engine is running at idle speed. Route the hose to a metal container. There should be some flow of fuel out of the flexible tube, but you should also look for any flow back up the metal tube, which indicates a blockage in the system somewhere downstream. Some vehicles have metal return lines joined by sections of rubber tubing. Check these rubber tubes for any distortion that could restrict the flow of fuel. Also, check the metal tubes themselves for blockage, particularly at joints or T-sections. Rough idle and excessive smoke can be symptoms that the engine is not getting adequate fuel. Sometimes that can be caused by something that's not there, a partial vacuum instead of a restriction. A fuel tank cap is another item that can restrict the flow of fuel. The cap is double vented to let air into the tank as the fuel is consumed by the engine, and to let air out to relieve any pressure buildup in the tank due to temperature change. It has been found that some caps can restrict the flow of fuel under certain conditions. It's easy to check. On a vehicle demonstrating a rough idle condition, simply remove the cap for a minute or two and see if the idle smooths out. If it does, then you've found the cause of the restriction. A new, properly vented cap should solve the problem. And be suspicious of lockable fuel caps. Many of them do not have the proper two-way venting. So, if you have a rough idling diesel or one that smokes excessively, see if it has an aftermarket locking fuel cap. Remove it while the engine is idling and check for an improvement in idle smoothness. Lack of power, complaints of poor performance, and an uneven idle can be caused by problems with the injection pump. But after examining pumps that were removed for replacement in 1982 on 6.2-liter engines, 35% checked out all right. There was nothing wrong with them. So, before making an injection pump change, be sure all other elements of the fuel system check out all right. Be especially certain there are no air leaks in the system. A lack of power, poor mileage, and an uneven idle may be traced to the timing advance piston in the pump. It is possible to check the operation of the advance piston without disassembling the pump. With the engine running at idle, push the rocker lever on the side of the pump inward to act against the advance piston. Be sure the engine's fully warmed up and the fast idle solenoid is off. Pushing in on the arm should have an effect on idle speed. If it doesn't, then the piston is stuck, which means the pump must be replaced. The advance piston has a very close fit in its bore and is therefore susceptible to sticking caused by foreign material in the fuel. Design changes are currently being made to the Stanodyne pump that will add an internal fuel filter to prevent foreign material from reaching the advance piston. A white smoke condition can be the result of a malfunction in the housing pressure cold advance system, or HPCA, on the 6.2-liter injection pump. The smoke is often accompanied by other symptoms: hard starting, rough idle, and noise. Housing pressure cold advance, HPCA, is also referred to as the cold advance solenoid. This feature is designed to advance injection timing about 4 degrees during cold operation. The HPCA is an emission control device. It helps provide better cold starts, and it improves idle when the engine is cold. In operation, the HPCA circuit is actuated by this temperature switch on the right rear head bolt. On current engines, the switch opens the circuit at 95 degrees Fahrenheit. Below this switching point, housing pressure is decreased from 10 psi to 0. This pressure decrease advances the timing 4 degrees. When temperature is above 95 degrees Fahrenheit, the temperature switch opens to de-energize the solenoid and the housing pressure is returned to 10 psi. Check the operation of the cold advance solenoid when the engine temperature is below 95 degrees. Turn the ignition switch on, then disconnect and reconnect the solenoid connector. Listen for the clicking sound. If you don't hear a clicking sound, check to see that you have voltage at the solenoid connector. Use a 12-volt test light connected to ground and touch the disconnected wire at the solenoid connector. If the test light indicates voltage, check the solenoid connector and ground. If okay, then the solenoid is faulty and must be replaced. Incorrect injection pump timing can cause rough idle, also excessive exhaust smoke. White smoke at engine idle most often can be the result of retarded injection pump timing. Pump timing for federal light-duty emission engines, the LH6 engine, is set with an adhesive-backed label placed over the stamped timing marks on the mating flanges of the injection pump and engine front cover. With the label marks aligned, the metal stamped marks should be slightly out of alignment. The mark on the injection pump must be 1.5 millimeters to the left of the mark on the engine front cover. That is, toward the odd-numbered cylinder bank, or the driver's side of the vehicle. If a timing adjustment is necessary, it must be made with the engine off. To make the adjustment, loosen the 3 pump retaining nuts, then rotate the injection pump to obtain the 1.5 millimeter measurement. The retaining nuts are torqued to 40 Newton meters or 30 foot-pounds. When pump timing has been altered, idle speed will have to be readjusted.
During the 83 model year, a change was made in injection pump models and in the timing specification. On all 83 vehicles using injection pump model number DB2-4126, the metal stamped timing marks should be aligned. This will give the correct timing setting on these models.
For California light-duty emission engines, the final injection pump timing is set during an engine test run. The original static timing marks may or may not align. Static timing marks are straight-line marks on the pump and engine cover flanges. Dynamic timing is indicated with a circle mark. The 2 halves of the circle mark should be aligned for proper timing. Disregard the straight-line timing marks. If the circle marks are not aligned, then with the engine not running, the injection pump should be rotated so the circle marks do align. All heavy-duty emission engines, LL4 models, both federal and California versions, have different injection pump timing specifications than light-duty emission engines. For all heavy-duty emission engines, federal and California, the injection pump timing is marked on a yellow adhesive-backed label. This label has printed timing marks and is placed over the metal-stamped timing marks on the mating flanges of the injection pump and engine front cover. The printed timing marks must be aligned. With the printed timing marks aligned, the stamped marks should be offset. The mark on the injection pump flange must be 2.5 millimeters to the left toward the odd-numbered cylinder bank of the mark stamped on the engine front cover. If the pump setting is not correct, loosen the pump attaching bolts with the engine off and rotate the pump to obtain the 2.5 millimeter measurement. If you alter the pump timing setting, the idle speed will then have to be adjusted.
During the 83 model year, a change was made in injection pump models and in the timing specification. On all 83 vehicles using injection pump model number DB2-4153, the metal stamp timing marks should be aligned. This will give you the correct timing setting on these models.